Now, from studying the entire universe, we're going to bring it back home and start discussing the solar system. So the solar system is the sun and everything that orbits around it. This is a very inclusive definition, but if we want to specify, this is going to include planets, moons, asteroids, comets, and all of the other stuff orbiting around the sun. So we would like to understand how it is that the solar system actually formed. Any good model that's going to describe solar system formation has to account for four things. First, the patterns of motions among large objects. Why is it that the planets and moons move the way that they do? Second, why are there two types of planets? We see a clear distinction between the inner planets and outer planets. How is it that we got these two types? We'll mention more about those in a second. Third, where do asteroids and comets come from? And then fourth, any exceptions to the general patterns that we see in the first and second points. So let's look at some of these patterns and so on. As we look at the planets in the solar system, all of the planets have orbits that are close to the plane of the ecliptic. If you remember way back, the ecliptic, or the plane of the ecliptic, is the plane that the Earth is orbiting on around the sun. Okay, so if you take the Earth's orbit and create a plane out of it, that is the plane of the ecliptic. All of the planets have orbits that are close to that plane. They're slightly tilted, but they are pretty flat, pretty close. In other words, our solar system is very, very flat. Another point is that all of the planets' orbits have eccentricities close to zero. So again, you're going to have to remember way back talking about Kepler's laws, an eccentricity close to zero means that the planet's orbits are nearly circular. They're not perfectly circular, but they are close. Another piece that we see is that all of the planets orbit in the same direction. So if we are looking down onto the solar system, all of the planets are orbiting counterclockwise. All of the planets go in the same direction around the sun. And then another pattern we see is that most planets rotate in the same direction that they orbit. So if you're looking down onto the solar system, all of the planets are going counterclockwise. They're also rotating counterclockwise. That's most planets. There are going to be a couple of exceptions, which we'll get to in a bit. As we look at the planets, we see that there are kind of two sets. We have one set that is close to the sun. These are sometimes referred to as the inner planets. And then we have the other set that is far away from the sun. These are often referred to as the outer planets. So we have the four inner planets and the four outer planets. The four inner planets are also known as the terrestrial planets. Terrestrial means Earth-like. So these planets are Earth-like. Now that doesn't mean that they have nice breathable atmospheres with temperate climates. They absolutely don't. But it means that they're going to be made of the same types of things as the Earth. So just like the Earth has a solid crust, all of these planets also have a solid crust, which we could land on. Now, all of these planets have high densities as well, indicating that they're made of rock and metal. The outer planets are also known as the Jovian planets. Jovian means Jupiter-like, so these ones are like Jupiter. These planets are very large, both in mass as well as in diameter. These planets range from 5 to 11 times the diameter of the Earth, and in mass they range from around 14 times the mass of the Earth to 319 times the mass of the Earth. Although these have very high masses and high diameters, they actually have very low densities. So down here on the bottom of this chart, we actually have the densities of the planets. On this scale that we're using, water has a density of 1,000. So all of these have densities close to the density of water, with Saturn actually being the least dense. Saturn is actually less dense than water. So if we threw Saturn into a giant cosmic swimming pool, it would actually float, which is kind of fun. Now, because of these very, very low densities, they cannot be made of rock and metal like the terrestrial planets. So we suspect that they're primarily made of hydrogen and helium, which on the Earth are gases. So you may have also referred to these as gas giants because they're primarily made of hydrogen and helium. As we look throughout the solar system, there are many small objects scattered throughout. We classify these into two categories. If it is small and rocky, we call it an asteroid. So asteroids are small, rocky objects. The highest concentration of asteroids is within the asteroid belt located between Mars and Jupiter. A comet is a small and icy object. Now, in astronomy, an ice is anything that is normally a liquid or a gas that is so cold that it has actually frozen. Most time when we talk about ice, we do mean frozen water. However, this could also include frozen carbon dioxide, which is sometimes known here on the Earth as dry ice. It could also be frozen methane or frozen ammonia. Now, the highest concentration of the comets is out in the Kuiper belt, which is beyond Neptune, and we think that there's another region right at the edge of the solar system referred to as the Oort cloud. Now, we also need to be able to explain exceptions. So, some exceptions to the general rules that we've mentioned. Venus rotates backwards. It has what we call a retrograde rotation. So when we look down onto the solar system, most planets rotate the same direction they orbit. All planets are orbiting counterclockwise, but Venus is actually rotating clockwise, which is weird. Similarly, Uranus is actually tilted on its side, so it's actually tipped over. So it rotates with its poles almost pointing at the sun, depending on time of year. Around the time of the summer solstice, its pole is going to be pointing towards the sun. There are some moons which orbit backward from the way that we expect. Moons should be orbiting around the planet in the same direction that the planets rotate, but we find that some moons are rotating backwards. We call this a retrograde rotation. And another strange property is that the Earth has a large moon. There are only 7 large moons in our solar system, and the only terrestrial planet to have one of these large moons is the Earth. This is weird. We're going to need to be able to explain it at some point.